Hi and welcome back. This module is on performance and I will deal with this as follows. First we'll have a look at some important terminology. It would not be very productive, I think, to simply look at some examples and demos without actually knowing what we're looking at. So in order to be able to see things in a proper perspective, we have to take a look at some of these keywords and features before looking at any of the tools. We'll talk about generic performance stuff, so measurements in general, irrespective of the environment you're in, so IOPS, throughput, latency, and the relationship between these. We'll also see how ONTAP works with objects, instances and counters, and how we can look at them from the command line. After that we'll be using some native tools that ONTAP offers. What I mean is we will look at commands like statistics from the cluster shell, sysstat, statit and stats from the node shell. And we'll also have some demos on that. As some kind of in-between, we'll discuss quality of service and configure that as well. Then we'll look at tools like OnCommand Unified Manager and Performance Manager. Now I hope I will not disappoint you, but I will be setting up OnCommand Unified Manager 7.2, which also has Performance Manager on board. To actually monitor the performance, we will not be using Performance Manager that much though. What I will be using is NABox. NABox is a tool like Performance Manager and it's definitely gaining in popularity. Mainly because it is very flexible and fine-grained. I'm not saying that it's a better tool than Performance Manager, but we will have a look at that and we will see some differences and then you can decide for yourself. And obviously we will have some demos on the different topics. So my suggestion is that we start. First of all, performance monitoring is a very complex thing because of multiple reasons. You first have to find out what can be monitored, then you have to monitor it, and then you have to think whether the results are okay or that they may be not okay. So it's very important to start with a baseline. What I mean by that is that your system is functioning fine and nobody is complaining. So you've sized your system for a predefined or desired workload, and the way things are is the way that they are supposed to be. So in fact you would have to register this state as being the perfect state, so to say. When you have a record of that state, it will make it easier to determine what may possibly be wrong on the changed performance monitoring output when you encounter problems. Also, it's important to keep a history of performance, so you can look back in the past and maybe see when and where things started to change, to maybe find the reason for the dropping performance. Now, there are some important terms that may help you in determining bottlenecks and think of a possible solution without causing any other problems. First, there's operations. With storage systems, operations can be of two different sorts: reading and writing of data, and other operations like lookups, attribute changes, creation and deletion of files, resetting pointers, and stuff like that. So reading and writing data obviously are different from changing the permissions of a file, or retrieving file handles, or changing pointers. So the tools that you will be using do not always distinguish between that. Then we have metrics. Metrics is the term that is used to describe the measurements that you are using to monitor your performance. Think of number of I/O operations per second, number of megabytes per second, but also the host or the volume or the storage virtual machine that you want to monitor can be regarded as a metric. Then we have something which is called throughput. Throughput is the work that is done over a particular period of time. So the work will be expressed in units like megabytes per second or I/O operations per second. So throughput is actually what is being done during a time interval. Latency is the time it takes to complete a unit of work. So throughput and latency are strongly related in the sense that, in general, if latency increases, then throughput will usually decrease. So if you have to wait longer before something is completed, what you can complete in that particular time will be less than if you need less time to complete something. And obviously that works two ways. If your throughput increases, then your latency will probably decrease. When you look at this graphical picture, which is from NABox by the way, you see that a an increasing of the one will decrease the other. Then we have something which is called concurrency. Concurrency is the number of outstanding operations at the same time. So this describes the number of operations that can be performed at the same time. You could also refer to this as tasks that are done in parallel. A higher concurrency is usually better than a lower concurrency. Very often this is compared to having multiple tasks for one single worker versus multiple tasks spread out across multiple workers. But whatever metrics you use and whatever way you look at it, you should realize that they're always related to each other. So you can't just change one thing and expect that the other stuff does not change as well. So usually all the metrics are related, and it's not always easy to explain why things change the way they change. Now in the next section we'll look at some command line tools that will help you monitor your performance from the cluster shell and from the node shell. In ONTAP we can find objects. Objects are the building blocks of your cluster and are always of a certain type. So we can think of an aggregate as an object or a volume, but also a queue-tree can be regarded as an object, or a protocol. A network port and a LIF, all examples of objects. Now a certain appearance of such an object is called an instance. So you can have multiple aggregates and multiple volumes and multiple ports and multiple LIFs. So for example, when we look at volumes, the X volume and the Y volume that we use all through this training are instances of the object volume. And every different object has its own relevant counters that will store information about performance and capacity of that particular object. But because you can have multiple instances of one object, these counters are kept per instance. So for example, the average writes for the object volume may differ between the xvol and the yvol instances. Now the stats command can tell you about objects and instances. For example, you can list objects, you can list instances of a particular object. You can also list the counters and have counters explained if you like. And if you want to monitor a particular object, then you can use the stats start command, and then you can get the values of particular counters, of particular instances, if you like. And then of course you should stop the registration when you're done. So let's have a look at the node shell and look at some stats examples. It goes like this. So we're logged into the cluster shell and we enter the node shell of node 1. And before we do anything else, we go to the advanced mode because we want to get all the information that's available. And you don't get that from the admin mode. So we first go to the advanced mode and then we run the stats list objects. And it will give us dozens of objects we can choose from. So these are all unique objects in the cluster. And the one we're going to look at is volume. So we're going to take the object volume and build our example upon that particular object. So now we can run the stats list instances of the object volume. And we see we've got 3 volumes in this particular node. Mind you, this is not the entire cluster, this is just for this node. So we've got the X volume as our only data volume. And we run the counters for the object volume. And we see we've got loads of counters, all based on protocols. And all the way at the top we have the generic counters that have to do with operations and with latency. Now let's take the average latency as a counter for the object volume. And we're going to have a look at that. So we want to have this particular counter explained. So we say stats explain counters for the volume object and the counter is average latency. First it gives us the name, then it says there's a description. This is what this counter actually does, and there's a property called average and the unit of measurement is microseconds. So now let's start collecting data. We can do that by running the stats start command for a particular object, and it starts collecting data for all of the volumes. So we run the stats show, so the interval will be 3 seconds and the number of iterations will be 5. So we are going to use the object vol, the xvol is the instance and the counter is the average latency. and it will display every 3 seconds, it will display us the latency of that particular volume. And it does that 5 times. So after that, of course, we stop the registration of the data and we're done. Now let's go to the next section, in which we will have a look at 2 more commands from the Node shell, which is systat and statit. And then we look at statistics from the cluster shell, which has some very nice features to watch your performance.